Okay, well, we had some rain last night, some reasonable rain. Sun's back. Baptism of fire for these. They were hanging out because, as I said, our weather symbols and is rubbish since they got rid of the 300 and another 300 employees at the ABC. So basically, I think they just do around Australia. They don't actually send on Southern Albert land at all. So they just look at, stick their head out the window. Is it raining or not? Yes, no, blah, blah, blah. Are there clouds in the sky? It's gone back to see, those sort of caveman basics, I think. So, they survived. Baptism of fire, sort of thing. Yeah, I like the colours in the centre. They've hardened up a bit, and they did get a bit crinkly. But I think they did a little bit better. So, fly traps, terrible. Yeah, they did it tough. They did really tough. But this one here I put in here, post baptism of fire sort of thing. It seems to be. We'll keep an eye on that. This one here I put in, getting quite red leaves there. I don't see that as a problem because I know if I can turn red into blue sort of thing. So if on the bottle work, we know if we can get the organism to go red, we can also get the organism to go to blue sort of thing. So that's what we're working on. So it's a stepping stone to bluing a fly trap. Now if you notice, the red is on the older leaves, not on the younger leaves. So that would imply we'll get bluing on the older leaves. Does that tie in with natural observation? Do the traps come out instantly dark red? No, they come out usually green to pale pinkish, and over time they go red. So that stays in line. So as the leaves get older, they become redder. So if we can turn red into blue, the leaves will come out very probably glaucous, and then go to a true turquoise blue over time sort of thing. So whether it would just be the petioles and the traps, or just the traps, I don't know. We'll have to work it. We'll find that out, I suppose. But that'll be probably over the summer. We'll be doing more bottle work to nail things down precisely, and then next season we'll have a go at bluing something. Now with this one here, I think it's also a stepping stone, my own personal experiment. I think the idea is going to be having a perched water table of polystyrene, a small quantity of sand, probably a brick's worth, I don't know, or less, a coir brick's worth, 600 cubic centimetres worth of coir sort of thing that you get from a standard brick these days. And then just top it with a very fine layer of coir, peat, or newspaper cellulose, or maybe some small bits of charcoal. Charcoal does work, but it takes a long time. It takes about 6 months to get going. Best to use old charcoal that's been wetted up for quite a while. And then just top the surface so you stop rain scouring. And I think that will be a basic standard, bog standard sort of pot. So basically what we've learned is they like an anaerobic environment, they like a perched water table because it keeps the top layer wetter and wetter for longer, but it's also, it's a well-drained anaerobic environment. Now, how do you get that? This is the thing, it's a well-drained microaerophilic to anaerobic environment. So that stops all the disease problems. That's why you don't want any organics down the bottom, because it's an anaerobic system sort of thing. That's why you want all your organics on the top. And basically you don't need much. As I said, we've learned all you need is enough to just cover the surface to stop rain scaring. So basically, and it doesn't have to be amended at all. So you basically amend the sand, but just put straight coir, peat, whatever else on. So it's going to get it very cheap. It's going to be a very cheap but effective, efficient system with a well-drained anaerobic perched water table system. So that's the way I'm heading. And we'll try set up a few more pots ready for the summer fly trap season, and go from there and transition over the summer and the next year to try to do it all again and blue something. So that's the idea. Maybe we'll get all these veins on here, on these plants here, to go, instead of being red, we'll get them to go blue. So we'll have a green plant with blue veins and white fenestrations. Wouldn't that be wonderful? But you know, maybe this is the way to do it. We start with one of these and move over to a flytrap and move over to Cephalotus that also has fenestrations. So we'll get like instead of getting an Eden black type Cephalotus, we might end up with a Eden blue or something like that. I don't know. They do say that the peristome on a Cephalotus does fluoresce under fluorescent light. So what colour would a blue pitcher plant, a blue flytrap, a blue Cephalotus glow under UV light? Would it be a different fluorescence, a slight variation on the fluorescence? You know, they fluoresce a certain colour. When the red is red, they fluoresce a certain colour, but when the red is blue, do they fluoresce a different colour? Or is the underlying fluorescence always the same? It's just the red and the blue change, and that's how insect is attracted. It would rather go to a blue fluorescence with red veining, or would it go to a blue vein plant with blue fluorescence? Does it think it's more, you know, more wicked, more attractive, more healthy? I don't know, to the insects